Hey guys, so I am back to show you how hard my elements are. There's 14 of them in this line right here, but there's 2 of them right here because this one at the start right here is not the softest. This one at the end is not the hardest. But this one is the softest and this one is the hardest. I put them aside just because I want to show you which one is first and which one is last. But these are all arranged based on their hardness, like starting from the softest to the hardest, right over there. So this one is indium. I showed you how soft indium is in many of my videos, and I'll just show you how soft it is. Yeah. If you listen very closely, you can actually hear a little bit of a cracking sound. Yeah, kind of like that. So, this one is boron. It's an element that is very, 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 very hard, but it's not really a metal. It's a metalloid, which means it's in between a metal and non-metal. It can scratch almost any one of these. Cobalt is pretty hard to do it on, but boron can easily do it on cobalt, but you can't really see the effect of it scratching it. You do it on a freshly cut surface. It barely scratches it, but if you look closely, yeah, you can see those scratches. Like, you see all those scratches right there? That's what the boron did to the cobalt. So, boron has a hardness ranking of 9.2. So that's why it can scratch almost any one of these, except itself. And also diamond, which it sits directly under. But let's put these aside, and I'll show you what the other ones are. So this one is dysprosium, which is soft, like you can bend these strands here. Well, that got stuck a little bit, but it isn't very hard. Well, I can't bend this, but you still can do this. Same thing for thulium, which I have right here. I have pliers right here. I can take this top part. Wait, let me tighten these. And now I'll show you. So let me get a grip on this top right here. You can kind of move that back and forth. You can kind of see the action of me moving it. This one is yttrium. I'm not able to cut it, but you can kind of scratch it with a knife. Like, watch. Yeah, I can scratch it like that. And same thing for this one, gadolinium. It's about the same thing, except a little bit more brittle. And some lighting. Okay. Can't really scratch it though. Relatively hard, but tantalum is hard enough that it's to the point where just a coin of it is not enough to bend. You see, I'm pushing on it as hard as I can, and I can't do it. And Also, if you look at the other metals side by side next to it, you can see that it has a slight blue color to it as well. And niobium is another one I showed in a previous video, but even though it is still quite hard, it's still quite malleable, and you can bend these things with pliers with a lot of work. Not a lot of work, but still. This is why niobium is fairly soft, but it's quite hard. But the same as titanium. And cobalt, which I showed you before. This one is hafnium. This one is a little bit interesting because it's extremely difficult to separate from this element, zirconium, which is always found combined with. And for zirconium, I'm pretty sure that hafnium can scratch zirconium a little bit. Yeah, it severely scratches it a little bit. You can see all those scratch marks, right? That's what the hafnium did to the zirconium. And next, we got germanium. And germanium is pretty unique because you see how it fractures like glass, right? It's because it's very brittle, but it's very hard. It's still not hard enough that you can get that you can not scratch it with boron, but boron can scratch it. See how it left a little bit of scratches on there. Yep. It left a little bit of scratches. But I don't want to do it enough that it's going to start shedding off a bunch of glitter, because this thing can break into a million pieces pretty easily. And then ruthenium, the most pricey element out of all of these 16 elements. I'm not going to try scratching it with that because of that. But I can show you that it is quite hard. I can barely bend that bar. It measures a ranking of 6.5 on the Mohs scale. But rhenium is next up, and it's another precious metal, but it's hard like that. But you can still get a little bit of scratching with this. Yep, you saw how I did that, right? Yeah. So that's about it. That's what boron can do to my elements. And by the way, this is not a metal, it's a metalloid. Yeah, both of these are not really metals. They're metalloids, which means they're in between a metal and not metal. But I included germanium on there just to resemble how easy it is to break. And if you scratch it a little bit more, you kind of heard that sound, right? I think that's because the surface of this cube of germanium is smooth, and it also tends to shed off glitter, kind of like glass. And maybe if I polish this thing a little bit more, I can get rid of the scratches. But, or maybe I can just buy some more germanium to do more experiments on, but it's still pretty cool. But if I introduce some diamond into here, then that diamond would easily get a good grip on this piece of boron, and it would scratch it pretty easily. Because diamond ranks as 10 on the Mohs scale, but boron's 9.2. It's also very light. Anyway, guys, see you later.